Okay, so R is all about data. So let's go and deal with some data. So I have a data file here called IHNO, and it has an extension .csv, and that just means comma separated variable. So if we were to say open it in Windows with Notepad, we can see that the top row is like what the variables mean. Then we have the data on subsequent rows. And each of them is separated by a comma, i.e. comma separated variable. You by default, you would tend to load these in. Excel can actually read them. And you can see the data set in a format that's probably pretty familiar to you guys. And what this is just a bit of a fun data set. This is like a fear of math and statistics. So we have a load of subjects who are taking tests, taking a statistics class, or let's just say they're taking an analytics class. Why they're taking it? Because they were required to, they were recommended it. There's an experimental condition as like how hard their exams are. I don't know how they got this past human subjects. I don't think I would be allowed to set different difficulty exams for different students. And then we kind of information about like a test they take. I guess it's got math and stats. We've got their scores. We have stuff like how much do they drink coffee? How much coffee do they drink? On a scale, how big their phobia is of statistics? How much previous math have they taken? We also have stuff like heart rate and anxiety measures, both their standard and directly before the test and directly after the test. So yeah, it's just a fun little interesting data set. Now, we have to, for it to work, previously we actually went to our working directory. So as long as the file is in the right directory, in your current working directory, then this will work. Now we use the command read.csv. I just said this is a CSV file, so it's basically the command to read a CSV file. There's lots of kind of what we call parameters, which is basically telling the function how we want to use it. So the first one we have here is header equals true. And the idea of read.csv is it loads in the file. Header equals true means we have the column headings in the first kind of row. So let's run that. And now we see IHNO 100 observations of 19 variables. So the variables are the columns in that little spread when you saw it in Excel, and the observations are the rows. Now, let's find a little bit more about it. The str command just tells you a little bit more about what information you have. Let's just get rid of that. So it says it's a type of data. Data frame is just the standard R way of storing basically data sets. And it tells you each of the columns. It gives you information about each of the columns. So we have gender, major, the reason you took it, the coffee. Now it actually tells you the type of the variable, and you can see int test says it's a number, it's an integer, and CHR just basically means it's a string. We might convert that string to something else later, but for the moment we'll just kind of go with what it gives us. We also have the view command, which now is quite important. V is a big V. Most R commands are all lowercase, but for some reason the V is a big V. And because V's are very hard to tell apart, this always seems to get a few people. And then we can actually see a copy of the data in like something that looks a little bit like a spreadsheet. So you can it's good for viewing the data. We also have head, gives the first 10 rows. Tail gives the last 10 rows. And summary kind of summarizes each of the columns. So we can see for each of my columns, we have some information. So we actually have, for gender, we have major, we have reason, we have the type of, these are character columns. Then we have the actual numeric columns. We get things like the minimum, the first quartile, all this stuff you remember from Business Stats 1, the median, the mean, the third quartile, and the maximum value. So that's kind of the basic summary. Okay, now sometimes we want to be able to get some summary information. We might want to know what the average heart rate was, what the average statistical test was. So one thing we can actually do here is we can actually find the means of the different columns. So if you just recall, let's go back to view. You see these data in columns, and obviously, for major or reason, it doesn't make much sense to calculate a mean. But for things like the math score, then it might actually make some sense. So let's go and let's do a mean. And one way of doing this is we use the function call means. Now, very important here, we have two brackets. You can see here we're referring to this is like some of the most important notation you will learn in R. When we have a data frame, we have some brackets. Then we have a comma in the middle, and it basically goes rows, comma, columns. So because we have nothing to the left of the comma, it means if we don't have to specify anything, it contains all the rows. But we're just including from columns 13 to 19. We could actually write that as C 13, 14, 15, 16, 17, 18, 19. That would be exactly the same, but that takes a lot of time. If we have the colon here, this just creates all the numbers from 13 to 19. So let's just have a look what we get. And there, for some of these continuous values, the heart rate and the anxiety, we can find the mean values of those. Another way of doing it, as I said with R, you've always got at least 5 ways of doing the same thing. Exactly the same, we're doing it on the same columns and rows. We use the apply function. Now, the apply function here is a lot more general. Apply can do lots of things, and one of the things it can do is it can calculate the means. Here, 2, and what we do is we pass the data set, then whether we're using rows or columns. If it's like, this is basically saying the dimension of the data. If it's 1, it's rows, and if it's 2, it's columns. And then what we're going to do is we're going to do a mean. Now here we could type in, say, sum, and we would get the sum of those values. But here we just want the mean, and if I've done everything correctly, we should get exactly the same as before. Now, we can create new variables from existing variables. Now here, we're creating one called Math Quiz 100, which is just to double the value of the math quiz. So we're basically, what this kind of $sign does is this specifies the column by name. If we knew the number of the math quiz, we could actually do something like, say it was column 10, we could just do like that. But it's easier if we know the column name, we just do the $. So this takes the math quiz. And we just multiply it by 2. So we get double the values, and we assign it again. This actually creates a new variable called Math Quiz 100. We use the $to say what we're going to call it, and then the equals sign. There we go. And we're also going to calculate another variable. We have the heart rate after you've taken the exam, the heart rate before you take the exam. So we're going to define heart rate pre to post, which is the difference between the post and, it's a change in heart rate. And let's just check at one of the variables we created. And there we have those doubled values. Okay. Let's just say we want a summary for the single column. So we have this guy here. Now the problem is summary command works on data frames. And this is now because we just picked a single column, R has automatically converted it into a vector. So there's two ways of doing it. We can convert it back to a data frame. And you see we've got a data frame now with just one column. And we create a summary. And there we go. We've got the summary of Math Quiz 100. We've got the mean is 58.14. The median is 60. And there's another way of doing this. Remember I said basically when we have the square brackets, it's rows, comma, columns. In fact, we can add another column and add something after this. And this says drop equals false means we don't go down to the next data level. So we don't go from the data frame to the vector. It just keeps it as a data frame. There we go. Now, the problem is, let's go back to our data. If you look at our data, we actually have quite a bit of missing data. Here we see this value here. It has, if you look, it's got some gray and it's got NA. NA means it's kind of missing. And again, depending on the function, sometimes R will ignore that. Sometimes it won't ignore it and it will actually crash your program. So you've got to be careful of missing data. So let's just say we've got IHNO, and this is what's called logical indexing. It seems complicated, but it's actually quite important. We've got the Math Quiz 100. You see we've got quite a few NAs in here. There's a function called is.na, which tells us whether it's NA or not. And basically, it lists the values and says, if it's NA, it's true. If not, it's false. Now, I'm going to take Math Quiz 100, and I'm basically going to take all the values that are not NA. This little kind of exclamation sign is basically saying not NA. So it's like the opposite of what I just did before. It's turned the falses to trues, the trues to falses. And we have our vector, and basically now we're using something called logical indexing. We're basically, every value we give a true or a false. If it's a true, we include it. If it's a false, we don't include it. So just pay attention to this, because the homework will use this idea quite a bit. And you can see now we've got all the values without the NAs. Now we can kind of plot the major. And let's just have a look at this. This is the major. So we have like a list of all the majors taken by the students. So we basically now have their majors and we have how much they scored in the math quiz. So hey, let's first look at the distribution. And again, this is going back to your Business Stats 1. If you took Business Stats 1 at Mississippi State or whatever you took at your university, the hist command draws a histogram. And this just shows the distribution of scores. And you know, I come from a data analysis background, so before I do any actual statistical tests, I like to look at my data. This one way is one way just of looking at it. It's, you know, the sort of thing you should have done in elementary school. We've got the range of the plot values. You can see this median around 60. And we can see most of them are to the center, and you've got a few at the edges. Now, this isn't very professional, you know? So let's make it a little bit more professional. And again, this idea of passing parameters. So we have the plot val, we have the main, we have, which is the histogram, we have the label, we have the border, the color. Now, what happens here is that R tries to work out, the histogram automatically. How many of these, what we call columns, how many breaks do we have in the histogram? More breaks, then you get like much thinner columns, and you get a little bit more information. But if you have too many breaks, then it just becomes too complicated. And prob equals false. Prob converts it to a probability. At the moment, it's a frequency. It's telling us how many items here, for example, scores are between 20 and 30. If you had probability, it would just say the proportion. So if it was like 7 out of 100, it would be 0.07. So let's draw the histogram. And yeah, it's just a slightly nicer histogram. We've given it a title. We've made sure we've labeled the axes with XLab, and the title is main, and we've plotted it in a nice color. Now, let's do one with probability densities. Now, again, this is just going back to your business stats 1 stuff. So this is exactly what we did before, but now we have prob true rather than prob equals false. So you can see the frequencies have switched to just a proportion. Now, what we want to do is we want to kind of see remember, you go back to your statistics, this idea of a normal distribution. A normal distribution is used really commonly in statistics. It's used for a lot of variables, kind of weight and height, we think are normally distributed. And when we're taking samples through the central limit theorem, we assume that our data are normal. But we'll talk more about sampling distributions next week. So we can calculate. Again, we have some nice functions. We have mean, which calculates the mean. SD, that calculates the standard deviation. You see, I'm not that terrible. We're not going to calculate any of these things by hand in this class. R is going to do everything for us. So what's our standard deviation? 18.96. And we already calculated the mean. Mean is 58. And we can actually use another graphics function called curve. And curve will plot a normal curve on top of the histogram. Now, what's it doing? Here, this function, we're using the dnorm function in R, and this just basically tells us to draw a normal density. Given the x's we have on the axis, so the x is from 20 to 100, and given the mean and the standard deviation from our data. We're going to color it in red. LWD we make it kind of 2 pixels thick. And add means we're going to add it on top of the additional graph. We're not going to draw a new graph. And there we go. We have a beautiful showing if our data was normal, what it's going to look like. Now let's show a few more graphs. Now ggplot, this is a library. And actually, I think we've got enough data. We've almost done 20 minutes. So we'll save ggplot for the 4th little session.